Hi, welcome to my channel Power System Hub. Today we'll see how to test all the function of Micom P643 relay, differential relay used for differential protection. Before going to the test, we'll see what are the setting available in my P643 relay, and according to that we'll test all the function of P643 relay. So first of all we'll see here I am using 2CT T1CT for differential protection. You can see here in my setting T1CT and T2CT I am using here. You can see here T1 polarity is 1000/1 and T3 polarity is 1000/1 also. So T1 and T3 I am using HV and LVCT having a CT ratio 1000/1 both are. According to that the matching ratio the relay will calculate. You can see the matching ratio is 3.95 for CT1 and for CT3 it is 0.653. So this value will after saving this value is change according to the CT ratio. That matching factor will be same because my CT ratio is same in the above settings. So now we will come to differential protection. What are the settings available? In differential protection section you can see IS1, that is a minimum pickup current for differential protection operation, that is 0.2. PU means per unit value. Regarding PU I have prepared one video also. You can go to my channel and you can see there what is the pickup value, how to calculate the pickup value. So here one IS1 means the minimum differential pickup current, that is 0.2 I have kept in my relay. Then K1 stands for slope 1, start of slope 1, that is the 20% I have kept here. IS2 is the starting of slope 2 and ending of slope 1, so that is the 1.5 PU. Then K2 is the percentage of slope to percentage, minimum percentage, that is I have kept it here 80%. Then high set value IS HS1, that is 13 PU, and IS HS2 value is 15 PU. By using this parameter we will test all the function of differential relay. How to test? We will go for a new relay and test this function. Let's go and we'll check it. If you will see the characteristics curve of a differential relay P643 relay, you can see here I have shown you in my setting IS1. This is the IS1. This is the minimum pickup value, minimum differential pickup value for a differential relay. From here, this is the start of slope 1. This is the start of slope 1. I have shown you the start of slope 1 in my setting, and this is the slope 1 curve. This is the K1. That K1 value I have shown you. You can see the value of K1 is 20%. Okay, this is the slope region is 20. So K1 is 20%. 20% slope was there. This slope 20%. Then K2 slope is 80%. This is the external region. When the fault occurs in this region, the relay is treated as an external fault. You can say as per the manual it is resistant region, means relay will not trip. If the fault is above this or on this white line, white box, this is the operating region. So we will test these all the function by using its parameter one by one, and we will check in relay how it will operate. So we will test this differential relay. I have configured all the settings I have shown you before in this relay, and we will test one by one function in P643 relay, and we will see how it will operate. So according to graph, we will test this IS1 minimum pickup value first, then we will go one by one K1 and K2 slope, and we will check high set 1 and high set 2 value later on. So first of all, that IS1, my IS1 setting is according to manual, according to my relay setting, my IS1 setting is kept as 0.2 PU. So PU means per unit value, and my relay setting is 1000 bar 1. I have shown you in my relay. So 0.2 into 1000 it is. If you calculate in primary, it is secondary. I have CT ratio 1000 bar 1. So my secondary value will be 0.2 into 1, so 0.2 amps. So I will inject 0.2 amps in any one CT, HP or IV CT, and we will check the differential and bias current in relay. For differential relay test, if you are using Omicron kit or double kit, that depends upon you what type of kit you are using. So if you are using double kit, so you have to open two current window. You have to select the setting configuration in relay test kit, and you have to two current option you have to select, because for differential relay minimum two current is required. So that is one CT1 you have to inject through one window, and for second CT you have to inject through second window. So here I am injecting CT1 current. So for IS1 pickup, minimum pickup, I will inject 0.2 amps directly, and we will see what is the bias current and what is the differential current inside the relay. Before that, I will make it all the default value. It is default value kept in my kit. I will make it to 0. Voltage is not required here, so I will make it to 0. Now I have injected 0.2 amps in relay, and we will see relay what are the bias current and differential current inside the relay. For checking bias current and differential current, you have to go to the measurement window, measurement 3. You can see IA differential is 0.13, IB differential is 0.067, IC differential is 0.067, I bias. As I am injecting single phase current, so it will R phase I have injected, but ID differential will be in R phase only. This differential minimum requirement is 0.2 for pickup. Now it is 0.13, so I have to increase this current up to 0.2 minimum. Okay, so we will let us ramp the current value of R phase, and we will see this relay will operate when this value reaches to 0.2. Now it is 0.13, so relay is not operating now. You can see relay did not trip here. Okay, now we will inject ramp the current value of R phase, and we will see. Now I am ramping the current value of R phase until unless relay will trip. Still my relay did not trip now. We will see at what value relay is going to trip. See, one sound came here, relay tripping. You can see here relay tripped now. And what is my differential, IA differential? 0.2. So this is the satisfaction of IS1 value, that in my relay setting template and characteristic curve also. In characteristic curve, the minimum differential pickup is 0.2. So you can see here IA differential is 0.2. So this is the threshold value when this value reaches, the relay got tripped. So this is the first point how to test IS1 or minimum differential pickup current for a differential relay. Similarly, you can inject for ICT2, CT2 and you can measure the value here, and through CT2 also you can check the differential current. Okay, next we will see the slope one, how to test the slope one. And for slope testing you have to inject this value with 180 degree difference with CT1. Suppose I am using this window for CT1, this window for CT2, because it is differential relay. For CT1 I am injecting the magnitude value in secondary 1 ampere, RYB phases, and this is phase angle 0, -120 and +120. Similarly for CT2 this magnitude value is also same, but phase angle would be 180 degree apart difference. If you put the same phase angle value, relay will trip because the current will be added. Because in same phase current will be added. In 180 degree phase current will be opposed. The current will cancel. So this thing you have to keep in mind while you are testing the slope. This is the condition of stable condition also you can say. If you will test the stable condition of the relay, in this condition relay did not trip because the phase angle of CT1 is 180 degree difference with CT2. Similarly 180 degree difference for Y phase, 180 plus 1 minus 120 it is 60 degree. Like that for B phase it is 120, so 180 plus 120 is 300 or minus 60 degree. So in this condition relay did not trip. We will see this is the stable condition, or we can say this is the method to check the stability test of 2CT in differential relay. For stability test you will inject this parameter value and run the kit. You see here relay did not trip now because both the current are in 180 degree out of phase. You can see here differential current is 0 because phase angle is 180 degree out of phase. You can see phase differential current 0. Bias current will be more because the principle you know for differential protection, if the phase angle is out of 180 degree, the bias current will be more. When the same phase or internal fault, the bias current will be less and differential current will be more, as you have seen before. So IB bias is 1, IC bias is 1. So my differential current is 0 now. So the relay did not trip. If you inverse the phase angle, then relay will trip because both the current is added. Then relay will got into differential region and it will trip immediately. So this is the stable condition. For checking of slope 1, we will make it unstable first. Okay, then differential current will appear here and we will calculate the slope percentage. So here now relay is in stable condition. During this condition we will check for stable condition. If my fault is in external zone, if the sensitivity of fault current is increases, then if it will reaches to my slope 1, then relay will trip immediately. Okay, I will calculate the slope 1 percentage what I have kept in my relay. So for calculating the percentage, I have to increase any one CT current, then only it will enter into my slope region. Okay, so I have to increase the current of RYB of CT1. So I will ramp it from here. Till now my relay did not trip. I will check at what current relay will trip. At that current I will calculate the slope. See, I have got a sound that relay got tripped. We will see in relay what are the differential value and bias value. You see, for opposite phase angle, relay will trip now due to suddenly increase in current, and that current enter into my slope region. Due to that, relay got tripped. You can see here IA differential current is 0.22, IB differential 0.22, IC differential 0.22, because I have injected 3 phase here. For IS1 I have injected for R phase only, so that's why IA differential is available. Here I have injected 3 phase current, so it will for differential will show for all 3 phases. You can see here 0.2 is the minimum pickup value for differential pickup. That's why relay got tripped. You can see the differential is value, and see, you will see the bias value. What that is the R phase bias, R phase current, bias current. I have injected 1 ampere, 1.2 ampere. So this is the bias current of R phase. This is the bias current of B phase. This is the bias current of C phase. By measuring this value, we will calculate the slope percentage. What are the percentage for this current? Okay. So for calculating slope percentage, once again I am repeating, for calculating the slope percentage, you just note down the I differential A value for any phase, any one phase. It will be common for all phases, no issue. You just note down the IA differential current and IA bias current. Okay, this is the current value due to which my fault will enter into the slope region and the relay got tripped immediately. So this percentage, for calculation of percentage, by using the formula we will calculate it. As per the manual, what the P643 say, to calculate slope 1, you have to know the differential current upon bias current. In terms of percentage, you have to multiply with 100. So we have checked in our relay, the differential current is 0.229 and bias current is 1.113. We will divide it and you will see after calculating the value will be 18.04. So friends, this is the second condition or second parameter, how to test the slope 1, and that this 80% is matched with my relay setting. Sorry, this is 20%, not slope 1 is 20%, the value is 20% as per my characteristic graph, 20% slope 1. So this is the proof that the relay setting is exactly 20% for slope 1. Now we will see for slope 2, K2, and we will calculate this percentage. Okay, and we will see the K2 percentage, how to check it. Now for slope 2 test, slope 2 is the 80% as per the relay characteristics. So for that we have to increase 200% of full load current. Suppose my CT ratio is 1000/1. So 200% of full load current means what are the full load current is running as per template. You have to set the 200%. According to secondary value, I have kept it here 2 ampere, and phase angle is just 180 degree out of phase. Then randomly I will increase any one CT value and I will check at what value the relay is going to trip. So I am ramping all 3 phases value. You can ramp it slowly. Okay, you can see here my relay got tripped. You can see in relay. You can see here 200% of full load current I have injected, my relay got tripped, and that I will calculate according to this current what is the percentage of slope. So when current is more for like city saturation, at that case it will comes into my slope to region. So I will calculate the percentage by injecting 200% full load current. So we will see what is the value of differential current. Here you can see IA differential is 1.18, IB 1.1. It will be same for all three pages, and bias is 2.5 because bias external fault is there, so bias current will be more. If more bias current was there and it will enter into the slope region, then relay will trip on slope 2 region. So we'll calculate the slope to percentage according to this value. So the manual says for calculation of slope 2, the value will be I differential minus KIS2, I bias minus IS2. By measuring the value from relay, and we'll put it here, I differential value this is 1.18 and I bias value is 2.59 in relay, then calculating it will be 80.50. So hence this satisfies the second calculation, and it is slope 2, and it will match with my percentage, slope to percentage. So this is the method for slope to test for P643 differential relay. Then we will test the harmonics, second harmonics and fifth harmonics. Now for second harmonic test, you just inject the normal current, normal rated current 1 ampere for both the CT, and it should be phase angle of 180° out of phase. We will inject it and see. At this condition relay should not trip. So this is the both the CT have 180° out of phase, as magnitude same also, but it will not trip. Okay, here as per the template for second harmonics means any one CT, suppose the frequency got doubled, suppose CT1 frequency got doubled or CT2 frequency got doubled, so you have to change the frequency of CT2 50, instead of 50 Hz you have to kept it 100 Hz. So you can see IA, IB, IC, CT frequency I have kept it double, that is 100 Hz, and second CT I have kept it as 50 Hz. This condition will satisfy for second harmonics, because any CT frequency got doubled, at that time what relay behave. In this condition, as per the manual, relay should be blocked, it should not be tripped, whatever the current. When the current parameter is within the limit. If current is suddenly increased during this condition, block condition, the relay will unblock and trip immediately if it is within differential zone. So we will check this condition by increasing IA, IB, IC, CT1 current, and we'll see relay will tripping or not. At this condition, you can see I have kept one alarm second harmonic blocks. Now it is on, because this is the second harmonic block condition achieved. So that's why it is on, and relay did not trip. Now you can see differential current. As differential current is more, but relay did not trip because it is the second harmonic condition. You can see the second harmonic PU also here. And now relay is block condition. When I am decreasing the value or increasing any value of any one CT, it should trip, though it is in block condition. So I will reduce the value of CT1 and we will check. At what current the relay will trip when it is second harmonic blocked. You see, for current 0.155 of CT1, my relay got tripped. Though it is second harmonic blocked, relay got tripped. As the differential current is above the differential pickup zone, relay did not trip at that time because second harmonic block. Relay got blocked due to second harmonic. When I have reduced the current of any one CT, at that time the differential current is same, there is no changes, but block got disabled and relay did tripped on second harmonic block condition. So we will calculate the percentage of second harmonic at what for this differential current, what is the percentage of second harmonic. It should meet our relay setting template. So note down the differential current PU 1.002 and we will check. This is the differential current PU. So here for CT1 current 0.115, my relay got tripped on differential on second harmonic block condition. So this is my pickup current for second harmonic blocks. So I note down this current 0.155 and I will calculate. So this value is 15.58. So this is my exact setting. As per the relay setting, the value is exactly 15%. So 15.58. So this is the method to test second harmonic for P643 relay. Now we will check the fifth harmonics. The procedure is same. The frequency only will be 5 time will be the frequency. So it will be 250 Hz for any one CT. And the second CT it will be kept. You just kept it 50 Hz only, and we will test and we will calculate the percentage. Frequency I have the set the frequency for CT1 IAIBC 250 Hz. This is the fifth harmonic frequency, but CT2 I have kept it 50 Hz only. Now we will check at what current. First of all, by this position relay should block first. Though there is a differential current, it should not trip. When I will reduce the current of any one CT to minimum value, at that time relay will trip only on block condition. Now you can see I have injected 1 ampere and out of phase 180 degree out of phase of both the CT, and frequency of CT1 is 250 Hz and CT2 is 50 Hz. Now you can see the fifth harmonic block came here, and though it is a differential current, but relay should not trip because the fifth harmonic is in block condition. It is now blocked the relay tripping. So relay should not trip here. Now you can see the differential current for all phases are same, bias currents are the same. Now we will reduce the current of any one phase and we will check. Now we check for this current, my relay got tripped. You see, relay got tripped and my fifth harmonic should reset, and I will check the differential current. You see, for this differential currents were same. Before that relay did not trip due to fifth harmonic block. When I will reduce the current of CT1, the block got disabled and relay got tripped on differential trip. So we will just note it down the pickup value and we will calculate the percentage. You can see the pickup value 0.155 and we will calculate the percentage of second harmonics. So this is the current at which the fifth harmonic block got disabled and relay got tripped. So this is the pickup current. So according to this pickup current, this is the rated current for CT2. So this divided by this is the that will be the second harmonic percentage. Here you can see here 0.25 divided by 1, rated current is 1, so this is 25%. So now this satisfies the second harmonics, fifth harmonics percentage, and we will check how to inject and how to calculate and how to the value of percentage of second and fifth harmonic. So friends, this is the method, this is the process how to test the slope, differential pickup, slope 1, slope 2, second harmonic and fifth harmonics. by using relay test kit in P643 relay. I will prepare one more video, theoretical video regarding this slope. Why the slope is we have kept 20%, why we have kept the slope 80%, why we kept the minimum differential pickup current is 0.2%, 0.2 pu. I will theoretically I will explain in later on one separate video what is the theory behind this. Today just I have explained you how to test by using relay test kit. For newcomer, you can easily test by following this method. And then second is high set 1 and high set 2. HS1, HS2, this is the high set current. During this time, when this current is reached, this is in my case it is 13 ampere, 13 pu and 15 pu. For 13 pu means my secondary is 1 ampere, so 13 ampere. If you will inject any one CT, CT1 or CT2, any phases 13 pu, 13 ampere, relay will trip immediately without checking this slope region, without checking this external edge. This is because this is already in internal zone. This is the internal zone. Okay, if any fault occurs in this zone, relay will trip immediately without checking anything, but that value should be within the threshold limit. This is the external zone. This is the external zone. This zone represent for external fault like CT saturation. When the fault is in external region, or suppose the fault current is out of region, when it will enter suddenly into the slope region, if it will satisfy within the slope region, then it relay will trip. Okay, this is the biasing region. Also we will say it is bias region or restraint region. Someone say, you can say it restraint region also, or external region or biasing region. This is the differential zone. For high set pickup, we will check it how to test HS1. As per our setting, it is 13 pu means 13 ampere. We will inject 13 ampere to any one phase of any CT and we will check. Now you see, I have injected 13 ampere for all three phases in CT1. CT2 I have kept it 0, and you will see in relay what the LED can. You see, here the differential, it will not calculate the differential current because this is the high set zone, that is non-directional, so it should not come within differential zone. It will trip immediately unconditionally without checking the differential zone. So you can see here there is no differential, there is no bias. You check in LED, you say HS1 trip come. Okay, this is the method how to test HS1. Similarly, for HS2 test, you just inject 15 ampere as per the relay setting and check in the LED and inside the relay whether HS2 comes or not. It should trip within HS2. It will not go to bias because this is the high set value, because threshold limit is more than the insulation level of CT or transformer to protect the transformer. So when this threshold value reaches up to this limit, it should not check any slope, it should not check any differential current. It tripped immediately on high set region. So friends, this is the method I have described how to test a P643 relay by using relay test kit, and step by step I have described you, and all the parameter setting I have told you how to test. And later on I will prepare one more video regarding the theoretically about the slope graph. So today I am just testing one relay, so I think that I will prepare one video. It will help the newcomer and other. If you like this video, please subscribe and share with your friend more and more. See you next time. Thank you.